Welcome back, MEFB 2013213 manufacturing processes. So let's continue from where we stopped in the last class. So we are talking about cold working. So as I had mentioned to you previously, cold working is shaping of an ingot or strand which undergoes plastic deformation at a temperature below recrystallization temperature. In conclusion, the shaping is done at room temperature. So what is so special about cold working is that normally cold working will not be performed from an ingot. Cold working process would be performed from an existing hot work product. So you get excellent mechanical properties, and from there on you perform a cold working procedure in room temperature. It can be an extrusion, it can be an extrusion, or it can be even a tube finishing, a wire drawing. Yeah, so it can be bending at room temperature. So basically the concept is performing a mechanical operation in room temperature, but the metal originates from a hot work product. It cannot begin with an ingot. So having said that, if you remember in the last class, we spoke about tube finishing versus wire drawing. So I told you the basic concept is extruding a material. One is a tube, the other one is a wire. Tube is a hollow material. Therefore, when you extrude it, what happens? There is a reduction in the diameter of the tube, and there will be an extension or a lengthening of the wire of the tube. There will be a reduction in the diameter and increase in the length of the material. And when you do an extrusion, you want to make sure that the inner diameter of the tube is not affected. So what do? You make sure that you insert a mandrel to support the inner diameter of the metal. Then we spoke about wire drawing. Wire drawing is just a thick solid wire, no inner diameter, and you are going to extrude it in room temperature. So the wire would be subjected under a draw bench, and once you stretch it, okay, draw bench has adjustable diameters. So assuming you want to reduce the diameter from 5 centimeter to 3 centimeter, so you adjust your draw bench to 3 centimeter and you extrude your wire through the draw bench. For this operation, you do not need a mandrel because you're dealing with a solid thick wire. Then we spoke about shear spinning, metal spinning. So if you remember, metal spinning, shear spinning is especially designed for bending materials to obtain a bell-shaped curve. Okay, so where do you find this bell-shaped curve? What kind of products have bell-shaped curve? Bells, light fixtures, okay, the lights in your house, those designer lights, yeah, it comes in the form of a bell shape. Okay, your kettle handle, bells, okay, all this some kitchenware, the cover that is used to cover your pots. Okay, so all this are bell shaped and it's performed using a metal spinning or shear spinning process. So what is the major difference between metal spinning and shear spinning? So if you remember correctly, metal spinning is again you're shaping the metal using a mandrel. Mandrel rotates to shape or transform it into a bell curve. And how do you get the curvature at the bottom? You are going to use a hand roller. So manually you're going to shape the edges to get the bell-shaped curve. For metal spinning, there will not be any reduction in the thickness of the metal. However, you must remember that in metal spinning, because the edges are shaped manually, therefore only a professional member or professional worker would be able, or a skilled worker would be able to handle this kind of production. Therefore, due to that, labor cost is going to be higher when you need to employ skilled workers. As opposed to shear spinning, if you remember, shear spinning is also producing products of bell-shaped curve, but now you're not going to do anything manually. Instead, the curvature, okay, is going to be shaped using an automated roller. So the entire process is automated. Accuracy is precision and accuracy is reliable. So obviously the process is going to be much more costly, but accuracy is reliable. So saying that was the conclusion of the last video. Yeah, so if you look at today, we're going to talk about stretch forming. What is stretch forming? Another cold working process performed in room temperature. So basically the metal sheet is clamped along its edges and then it's stretched over a die which moves upward and back and downward. So if you look at it, this is your metal piece. Yeah, it is clamped. Okay, there's a fixed adjustable gripper and it's clamped on both sides, and you have a so-called mandrel. We call it a piston and a mandrel to shape it. So the moment you push up the piston, if you have you push up the piston until and if it's a very slight push, a very slight force, let go, it'll come back to original position. So remember your stress strain curve. If you have insufficient force applied on the material will bounce back to its elastic limit. Okay, so no shaping occurs. So if you keep doing it over and over again as you increase the forces until you reach the plastic limit of the material, and when it hits the yield point, then permanent deformation occurs. So once you have exceeded the yield point of the material has permanently deformed and you have a bell-shaped curve. So the required pressure for stretch forming P equals to 1.5 YA, where Y is the yield strength of the metal and A is the area. Okay, so you can combine a few processes to produce a part. Yeah, so here a combination of stretch and raw forming can be employed. Number 6, the next one, swaging and cold forming. What is swaging and cold forming? Swaging is a special type of cold forging in which the metal is formed and shaped in the cavity of a die by means of successive hammer blows. So just like hammer forging, yeah, you're going to use a hammer to shape it into a specific shape. Sizing is a cold working used to finalize the dimension of a part with slight compression. So the next one, you have a rotary swaging, and cold forming this is something like upset forging. Yeah, so you can produce nails, bolts, rivets and other fasteners using a cold forming. If you remember, upset forging was performed in hot working. Yeah, so upset forging was performed in hot working where the metal is heated above recrystallization temperature and you shape it. You use a mold or a die and you shape the head, okay, of the nail, and then later you do the threading of the nail. So you allow the metal to cool back to room temperature and then you do the threading for the nail. But cold forming is also the same action, but you're going to do it in room temperature. So there is no heating, material is not going to be soft and it's not going to be easily shaped. So you're going to use, in cold forming, heading is an upsetting operation of the end of a rod in order to produce a larger cross section. So here you're going to do it in room temperature. You need to use heavy equipment, heavy machinery to shape the product. And examples, nails, bolts, rivets and other types of fasteners. Next one, you have hobbing. What is hobbing? Hobbing consists of pressing a hardened punch having a particular tip geometry into a block of metal. The cavity produced is then used as a die. So you need to get the die to produce. In fact, hobbing is you're producing a die, and the die is going to be used for producing your final product. What is your final product going to be? Your final product can be like a stamping. Yeah, your final product can be a stamping. So hobbing is performed in room temperature. It can be like a stamp. Okay, like those of you who have a stamp. Yeah, if you see your lecturers, once they sign, they would stamp the document. Yeah, so all this kind of stamps, the official stamp of a company, all these are produced using a die that is manufactured from a hobbing process. Next one, coining. What is coining? Coining is compression of a soft metal and is performed in a completely closed die cavity. So for you to perform coining, you need to have the upper half and the lower half of the mold, and you, as a result, you'll obtain a shallow configuration. So this is typically the process of producing coins. Take a look at your coins. If you haven't really looked at your coins, look at your coins. It has impressions on both sides of the face of the coins, but it's not a deep impression. Yeah, it's a surface impression. And how do you produce it? Using a coining process. So if you look at this is your upper die. You have a die holder, and this is your lower die, and you put your coin, the coin part in between, and then it's like a stamping process where you get your coin will end up getting an impression on the upper half of the coin and the lower or the bottom half of the coin. Next, you have embossing. What is embossing? Embossing does not require high pressure because it's performed in open dies. So normally, if you look at your car plate, motorcycle plate numbers, yeah, those are produced using an embossing technique. Okay, so those are produced using an embossing technique. This is an example. So embossing requires two matched dies, a male and a female counterpart, and one of the dies is heated as the paper is pressed between them, resulting in a raised impression. So just not number plates. Yeah, you can even use it. If you look at certificates, you have that chap mohor thingy there. Yes, that is a effect of embossing. So embossing can be used even in your official documents as well. Others, riveting. Riveting is heading of an end of a rivet placed in a hole made in two parts to be fastened. Roll forming. This is a high production process for fabrication of flat metal strips. Plate bending. Okay, what is plate bending? So if you look at it, plate bending, you have three rollers here in a plate bending. So you're going to put your plate through this. Okay, your plate will go through this. Your plate will be resting on these two bottom rollers. Two bottom rollers are stationary and it rotates in its axis. The top roller is rotating in its axis and it can move up and down because this top roller here will determine, okay, this top roller here, what does it determine? It will determine the diameter of bend. So when you put your metal through this, the metal will rest on the both stationary rollers which only rotate in its axis. And what decides the diameter of the bend? This top roller which will move up and down, and it will create your diameter of bend for your product. Okay, so the last one is seaming. It's a process of joining two edges of sheet by flattening them by compression. So you just take two sheets and then you can flatten it by compression. That is a seaming process. So this ends the cold working chapter. Again, this will be followed by an assignment. I will post your assignment on Friday. So please make sure that you have gone through all your cold working chapters and hot working chapters, because your assignment is going to be based on cold working and hot working processes. Yeah. So until I meet you in class tomorrow, thank you and have a good day. Bye.